So before we start on this, the derivatives of a to the x and log a of x, I want to derive some things. But before we start on this, we've got to recall a couple things. So we want to recall that the derivative of e to the x is in fact just e to the x. And the derivative of e to the cx, right? Recall that derivative of e to the cx, if we use the chain rule, e to the u, we end up with c e to the cx. So that constant becomes a multiplier and is still in the exponent. Okay, so we've got to remember those two things. Okay, one other thing we need to remember is that the natural log of e is 1, and e to the natural log of x is x. Okay, and if we change this one up, natural log of e is 1, natural log of e to the x is x. And so you'll see these similar properties here, right? Because natural log and e are inverses. So the natural log of e to the x, this guy comes out as a multiplier and it's just the only thing left because natural log of e is 1. Vice versa here, right? This is 1 and you're just left with x. So we've got to recall those things and then we can derive this derivative. We want to know not the derivative of e to the x, but the derivative of any number raised to the x. So 2 to the x, 5 to the x, whatever be the case. Okay, so we're going to start with the derivative of a to the x power. Okay, so any constant to the x power. And we're going to rewrite this as the derivative of e to the natural log of a to the x. Okay? Now, so far so good. The reason we're doing this, remember, this is just 1. So I haven't actually changed this at all. I'm just rewriting it. Now the reason I have rewritten it this way is because I know the derivative of e to the x is e to the x. The derivative of e to the cx is ce to the cx. So I'm going to use these properties, and that's why I'm rewriting it that way. Now, one other thing. Remember, the natural log of something raised to a power, right? Again, let's come up here where we can recall the natural log of 5 squared is 2 times the natural log of 5. Okay? Fair enough? So, that is going to cause me to rewrite this. That same concept is going to cause me to rewrite this as e to the x times the natural log of a. Okay? X times the natural log of a. Fair enough? Now, so far so good, right? Now, this derivative can be rewritten as e to the u. E to the u. Okay? E to the u. Okay? And what is the derivative of e to the u? It's e to the u times u prime. Okay? So, this derivative is now e, and I'm going to write it, and remember this is something times something, so you can write it in any order you want to. I'm going to write it in opposite order of that, and you'll see why in a second. So natural log of a times x, okay, times u prime, okay. U prime is the derivative of x ln a. Okay? So I'm going to go off on a little side note, a little tangent here, okay? Product rule. The derivative of x times ln a, this is a, and this is b, right? We have two functions, a times b. And this derivative is going to be a prime b plus a b prime. Okay. So the derivative of x is 1 times ln a plus x times b prime. Now, natural log of a number is a constant. The derivative of a constant is 0. So this u prime is just ln a. ln a. Okay? Now, here's the fun part. Remember, if I can find it, e and ln is just 1. This whole quantity here is equal to a to the x. So, if I take that same tact, and let me back up, okay? I rewrote this, right? I rewrote this as x times natural log of a. So I'm going to move that back. So it's going to be e to the ln a to the x times ln a. This goes away. This goes away. It's 1. So what do we get? A to the x times ln a. Okay, that is the derivative of a to the x. Okay, that is a derivative rule. So, if I asked you, let's just try one, the derivative of 5 to the x power. Right, so there's a, there's x. What's the answer? A to the x times the natural log of a. Now, we have a cool new derivative rule, right? So if we had, let's say, d dx of, let's try something a little different. What if I said 4 to the 3x? How would you have to work that one, right? Well, you'd have to look at that as 4 to the u. d dx, 4 to the u, right? And what would that derivative be? Right? So the derivative of a to the x is a to the x ln a. So this would be a to the x times ln a times u prime. Right? So it would be whatever the rule is times u prime. Cool. So that would be what? 4 to the 3x times the natural log of 4 times, well, what is u prime? U prime is the derivative of u. What's the derivative of 3x? 3. So piece all that together and you get your answer. And your answer is 3 times 4 to the 3x times the natural log of 4. Okay, so there'd be that derivative. Okay, so that's the first thing, derivative of a to the x and any subsequent version of it. Okay, derivative of a to the x. Cool, so we proved that. We worked out a few problems. I'm going to pause us there, and we're going to come back and do the derivative of log a of x. So if you have any questions about the derivative of a to the x, leave them in the comments or send me an email and we will figure it out. Thanks.